Today, what we're going to be looking at is proving triangles congruent by angle side angle and angle angle side. There's two postulates that we have. The first one is angle side angle, which is short ASA, congruent postulate. It says if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So, if angle A is congruent to angle D, AC is congruent to DF, and angle C is congruent to angle F, then triangle ABC is congruent to triangle DEF. The other theorem we have is theorem 4.6, which says if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of the other second triangle, then the two triangles are congruent. So if angle A is congruent to angle D, angle C is congruent to angle F, and side BC is congruent to EF, then ABC is congruent to triangle DEF. Now, yesterday we talked about the included angle. Today we're talking about the non-included angle. So in this case, the included angle would be if I had AB and AC, the included angle is angle A. The non-included angle is the angle that is not between these two sides. So if I have my side as being, well, if I have this angle and this angle, the included side would be AC. It's not, though, because we're looking for the non-included side. So for angle, angle, side to work, we have to have an angle, we have to have an angle, and then we have the side. So angle, angle, side, and also angle, side, angle. Let's look at a few problems. Can the triangles be proven congruent with the information given in the diagram? State the theorem if they can. So, in part A, can these be shown using either angle side angle or angle angle side? Well, just like yesterday, we know that vertical angles are congruent. But even though I have vertical angles, all I have are three angles. Now, three angles are not enough to have enough information to prove that these two triangles are congruent. So in this case, can the triangles be proven congruent with the information in the diagram? No, it cannot be. For part B, we know that we have an angle that's in both, we have an angle that's in both, and they're sharing a common side. So if you look, we now have angle, angle, side. In this triangle, we have angle, angle, side. So we know that these can be proven true by using angle, angle, side. Part C. Again, what we have is we have a case where we have vertical angles. So if I mark those vertical angles, that helps us see a little bit better. I have an angle, I have a side, and now I have an angle. In this other triangle, I now have an angle, a side, and an angle. So yes, I know that these can be proven to be congruent by angle, side, angle. All right, example 2. Can STW and triangle VWT be proven congruent with the information given in the diagram? State the theorem. So let's first identify where the triangles are. So if I have STW and VWT, we're looking at these big triangles right in there. So we want to know, can they be proven to be congruent? Well, we're given 60 degrees. We're also given a 90-degree angle in both. And you should also notice that they both share the side TW. So with this, I have a side, I have an angle, and I have an angle. Well, we don't have side, angle, angle, but we do have an angle, angle, side. So the same is true in this. We have angle, angle, side. So we can say angle, angle, side. On part B, we want to know, can we compare these two sides? Well, we have an angle in both, but remember, we always want to look for that side or the angle that they both share. In this case, they both share this side right here. So this would be an angle side, angle. This would be also angle, side, angle, so I know that these two triangles are congruent by angle, side, angle. Example 3. State the third congruence that is needed to prove that FGH is congruent to LMN using the given postulator theorem. So, we know that GH is congruent to MN. First thing I like to do is I like to mark it on my triangles. So GH is congruent to MN. I know angle G is congruent to angle M. I also know, or I also have to know, that I'm trying to do it by angle, angle, side. So in order to do angle, angle, side, I can't put it here because that would be angle, side, angle. So I have to go angle, angle, side. So I need to know that F and L are congruent. So I need to say that the measurement of angle F needs to be congruent to angle L. If I do the next one, it tells me FH is congruent to LN. Again, mark what you know. FH is congruent to LN. Angle H is congruent to angle N. And we're just trying to solve this by using side, angle, side. So I have a side, I have an angle, I have to know this side right here. I have a side, I have an angle, and I have to do this side right here. So this is an included angle because it is surrounded by two sides. So I have side, angle, side. So what I have to know for this last one is that GH is congruent to MN. Example 3. How can you prove that the indicated triangles are congruent using the given postulator theorem? So we have a lot of triangles in here. Let's identify what we got. We have A, F, E, and D, F, B. So we're looking at this small little triangle here and this small little triangle here. Now if we notice, they have an angle that they both share. We have a side that is in both. We have another side that they both share. And something else, we also know that they both share that vertical angle. Does it help us? I don't know. Let's find out. So we're trying to do side, angle, side. So how can we prove that the indicated triangles are congruent using the given postulator theorem? So if AFE is congruent to this by side, angle, side, we could say that AF is congruent to DF, because we know that is a side. I could do my angle, so I could say BFD, or let's go AFE, is congruent to BFD. This would be my angle. And if I did my side, my other side, since I already have AF, I'm going to do EF is congruent to BF. And this would be my remaining side. For part B, I want to show that AED, and BDE are congruent by angle, angle, side. So I'm looking at these big triangles right in here. So one thing that they both share is this side down here, and I want to do it by angle, angle, side. So I know that they both have an angle here that they both have in common. I also know that they both have a 90-degree angle in here. We know this side's 90, so because of a linear pair, I know this is 90 as well. So I have angle, angle, side. So if I do this, what I can do is I can say that the angle A is congruent to angle B. This would be my angle. I can say that my other angle, which is going to be AED, I got to make sure and use 3 points because if I just say 1, E could refer to this angle or this total angle. So there's 3 possibilities. So I got to make sure and be as specific as possible. So there's my other angle. So I have AED is congruent to BDE. This would be another angle. So angle. And if I do my last side, I know that ED is congruent to ED. And this is my side. So this is how I would show or how I would prove that these 2 triangles are congruent. Example number 4. Tell whether you can use the given information to determine whether ABC is congruent to DEF. Now, if you're like me, I need to draw a picture anytime I'm given 2 triangles that are not drawn. So if I have A, B, and C, and D, E, F, I need to be able to mark what I have. So I know A is congruent to D. I know AB is congruent to DE. And I know AC is congruent to DF. So just by looking at it, by drawing a picture, which really helps, I can now use the fact that I have side, angle, side. So with side, angle, side, I know that is something that we learned yesterday. So since I have side, angle, side, I know that these 2 triangles are going to be congruent. Because side, angle, side is something that we have. So side, angle, side. Let's do the other one. So if I do it again, I'm going to do, it doesn't have to be perfect, just something so you can see what you're looking at. If I have A, B, and C, and D, E, and F, it tells me AB is congruent to EF. All right. BC is congruent to FD. All right. And AC is congruent to DE. So if you notice, now we have side, side, side. We also have side, side, side. So I know that these 2 triangles are congruent by side, side, side.